Hi, myself Manjunath from the Department of Electrical and Electronic Engineering of KLSVD IT Haliyal welcomes everyone for this session on the subject testing and commissioning of power system apparatus, which is an elective for the 7th semester with the subject code of 17EE752. In the previous session, we had two topics. Among them, the first one is vibrations, that is, especially in the case of electrical rotating machines, vibrations amplitudes will be more because of its rotation as such. Sometimes there will be more vibration because of the problem associated with the particular the motor or maybe electrical rotating machines. Those may be due to the bearing problem, or maybe due to the shaft problem, or maybe due to the unbalanced rotor, or maybe due to the uh, foundation bolts, or what you call it as loose foundation bolts. Those are the causes of the vibrations. And these vibrations should be suppressed with different methods after measuring with the indicating meters or vibrometers or maybe any of the gadgets which are available in the market. Afterwards, we have seen the balancing of a rotor of an induction motor. The balancing is a must, which is one of the cause which causes the vibration in case of induction motor. If the rotor is unbalanced at the time, it may cause a vibration. So if this vibration becomes more than the specified permissible limit, it may cause the damage to the rotor as well as the shaft as well as the bearing gears. That's why the balancing of a rotor comes into picture. The balancing of the rotor is done with the help of two methods. One we call it the static method, that is, if the speed of the electrical rotating machine is less than 1000 rpm at the time, you're going to have a static method of the balancing the rotor. Otherwise, the more than 1500 rpm machines, the dynamic the method is applied for the balancing of the rotor. That's what you studied in the previous session. In this session, we are going to speak about, or maybe going to have the need of testing of an induction motor. That why the testing of an induction motor is essential. Then afterwards, we are going to have some tests that like load test, no load test on an induction motor. Then afterwards, we're going to have the how you can measure the power factor at which the induction motor is operating by the different methods. Those are the things we are going to study in this class. And after the class, the student should be able to know why that the testing on an induction motor is done, what is the importance of testing, and afterward they should know that what are the parameters or maybe what are the information we get it from a load test as well as the no load test on an induction motor. Then afterward you should be in a position to explain how the power factor of the induction motor can be determined by different methods. In this class, let us go, that is the need of testing. I think everyone knows that once it is manufactured, I should know the performance of an induction motor or any electrical rotating machine when it is designed or maybe manufactured and assembled. Therefore, it becomes very important to test a particular induction motor or maybe any of the electrical rotating machine to check its performance, whether or not it gives the performance according to the design criteria or not, or whether it is operating at its rating and its design. Therefore, a testing becomes the important there. Now, these testings are they're categorized into many, that is what you call the routine test as well as the type test. Among them, we are going to have the first one, the measurement of insulation resistance. Measurement of the insulation resistance. This insulation resistance is measured between the two parts separated by an insulation. When I say the insulation resistance, it is the resistance that exists between the two conducting parts separated by an insulation. That we call the insulation resistance. This insulation resistance of electrical equipment refers to resistance between the conducting part and the earth sometimes, or between the two conductors separated by an insulation. It is always expressed in mega ohms. It is always expressed in mega ohms. Now this insulation resistance gives out a quality of insulation and the degree of dryness, and it is represented by I suffix small n, or that INR, the insulation resistance. Now we see that the following are the factors that affects the insulation resistance measurement. That is, the insulation resistance depends upon the following factor: moisture and the temperature. As we have already discussed in case of transformer chapter, the insulation which is provided in the induction motor or maybe any electrical equipment, it absorbs certain amount of the moisture content. When it absorbs, its insulating properties decrease, or maybe what I call it as insulation resistance decreases. The magnitude of a test voltage, the duration of application of voltage, and aging of insulation and mechanical stresses. All these will affect the insulation resistance measurement of the insulation. Now we'll go for the next how this the insulation resistance is measured. How this insulation resistance is the measure. There are different methods are available for the measurement of the insulation resistance. It may be the direct indicating ohm meter. The ohm meter, you can use it, which is capable of measuring the resistance in terms of a mega ohm. That may be sufficient with having a self-contained rectifier using the external AC supply. That is ohm meter, which is capable of measuring the resistance in terms of a mega ohm. If it is available, that may be used as the device for measuring the insulation resistance. Any bridge method which is capable of measuring the resistance in terms of mega ohms, that may be used. Otherwise, the laboratory experiment voltmeter and ammeter method also can be used, or generally we call it as VI method, and sometimes direct indicating meter with the self-contained battery, and sometimes other equipment which normally we use is a megger. Normally uses the megger. You can see that the megger, this part is a megger here. It has the hand-driven generator, and will be having a current coil. This is the current coil, and this is a potential coil. It will be a potential coil. How to measure it from a megger is, now suppose these are the two terminals across which you are going to connect the resistance of the terminals which are used for measuring the terminals across which resistance is to be measured. Here you can see that this is the one terminal and this is the one terminal. Suppose I'll short it now here. I'll short it. Now you can see that the current coil is connected in series with the generator. You can see it is connected in series with you can see that this is the, check out my cursor. You can see that it is connected in series with this thing. Now the potential coil, it is connected in this the shunt, that is the parallel to the supply voltage of this one. This is supply voltage. Now these two, the potential coil as well as the current coil, produces the deflecting torque in opposite direction. We'll see that one, how these two produces. Now for example, I'll make a short here. I'll make a short. When I make a short, what happens? The short means the resistance is zero. When I crank it, this develops the voltage of 500 volts. And due to which the current flows through this one. Since it is shorted here, it becomes a lowest resistance part. Hence, the current flows in the direction. Show me this one. When this is short, is there, the current flows through in this one. You can see this direction and this direction, and this direction, and the current in the current coil becomes the maximum. Current in the current coil will become the maximum. Hence, deflecting torque that produces on the indicating meter, and it tries to push this needle towards the zero position, because when I said that short, it is a zero resistance. That's why we say that current coil produces a deflecting torque in a clockwise direction. Hence, when it is shorted, current flowing to the current coil maximum and that of the potential coil is minimum. Hence, a torque developed on the needle is moving the needle towards the right side, then it shows a 0. Similar fashion, if it is kept open, at the time current flowing through this, the potential coil becomes the maximum. The open means it is infinite, therefore this needle moves towards the infinite position, the position that indicates that is resistance is infinite. In between the things, as you connect here, depends upon the torque developed in case of current coil and the moving coil. The needle shows some value. Needle shows some value here. Needle shows some value. This is about the how the method gets operated. The other parameter which helps to determine the quality of insulation is also degree of dryness, is the polarization index. This polarization index helps to know the degree of dryness. It's a good tool to indicate the degree of dryness. It is a ratio of two insulation resistance. The Pi should be more than certain value. Otherwise, it implies that the insulation has absorb the moisture content. For example, you can say Pi, that is INR for 10 minutes to INR 1 minute, should be greater than 1.5 if a machine uses a class A insulation. Suppose if an induction motor using the class of insulation A, at the time Pi measure for 10 minutes to Pi measure at 1 minute should be greater than 1.5. When it becomes a greater than 1.5 for this class of insulation, then we say that the insulation has a good electrical properties. No need for drying. If it becomes less than 1.5, we are sure that the moisture is absorbed, moisture is absorbed by insulation, hence the drying is essential. Similarly, that is the Pi, if it is more than 2.0 for class of insulation B, then no need for drying. Therefore, the other one is if the Pi for a class of E insulation, if it becomes more than 1.75, no need of a drying comes into picture for an induction motor. Similarly, if the Pi becomes less than the above values for any different class of insulation, at that time the drying of an induction motor becomes the essential. That's about the Pi and the measurement of insulation resistance. Now let us go for our next testing, that the measurement of winding resistance. That this winding resistance is becomes very important to measure to know the losses in case of an induction motor. That is, the winding resistance may be the stator winding or maybe rotor winding measured by different methods. That is, maybe using the Kelvin double bridge method and the drop of the potential method, or you can use it a voltmeter and ammeter method. That is the simple voltmeter and ammeter method is shown here by you can take the stator winding and rotor winding, which is star connected. I am going to apply voltage and close the switch, and I measure the current flowing through these two windings. Therefore, I can find it out resistance of the winding with a DC supply, or DC is equals to V by 2I. Because the two windings are there, that is R by V by 2I, or DC equals to V by 2I. Considering the skin effect and the proximity effects, or AC can be found as 1.5 times the multiplication of RTC. Likewise, by this one you can measure the winding resistance, of an induction motor, stator winding or maybe rotor winding. Voltage ratio test. Now this test is conducted on only a slip ring induction motor, because the squirrel cage induction motor doesn't have any of the terminals brought outside from the rotor winding, and it becomes very difficult to check what is the voltage that developed in case of the rotor winding. But it becomes simple in case of a slip ring induction motor, since we are going to bring out 3 terminals or 4 terminals depending upon the type of rotor connection, whether it is a star connected or maybe delta connected. If it is delta connected, we will be having only 3 slip rings. If it is star connected, we will be having 4 slip rings. Therefore, here this test is conducted on only a slip ring induction motor. In this test, rated voltage at a normal frequency is applied to the stator winding. I apply the stator voltage here. Then I go on measuring the voltage across each slip ring, maybe line to line or maybe the phase voltage. If I measure the phase voltage or line voltage, that should be according to the design condition only. Then only we say that voltage ratio test is perfect, or the manufacturing or maybe assembling of the rotor winding is the perfect. That is, I give the input voltage of stator winding, then I go on measuring the voltage for which that slip ring is designed or maybe induction motor is designed by measuring the line voltage across the two slip rings or maybe phase voltage. Depends upon the way in which the rotor windings are connected. If it is according to design condition, then we say that rotor is perfectly designed or maybe induction motor is passed the complete voltage ratio test. Otherwise, if it gives a different value other than the specified value or maybe nameplate details, that has to be brought to the notice of the manufacturer. That's about the voltage ratio test. Let us come to the running up test. This test is conducted on a squirrel cage induction motor only to ensure that they are capable of starting against the specified load torque and to check the crawling and the noise in the induction motor. Now, it is to check whether the squirrel induction motor is going to start at the specific load condition if I apply the 70% of its rated voltage. In this case, it is a simple test. I apply the 70% of a rated voltage. I'll check it whether the motor is going to start or not. If I apply a 70% of the rated voltage. During this or maybe in this test, the time taken by the motor to reach the rated speed and the current is noted down. Just I am going to check it whether the motor is going to start when I apply a 70% of rated voltage to the stator winding of an induction motor. That's the main criteria behind this one. The intention behind that one, to check whether it starts at when I apply 70% of rated voltage to the input side, stator winding. Load test. Let us have the load test. Load test is conducted on the induction motor up to certain capacity only. I cannot go above certain capacity to conduct the load test, because as the breakdown arrangement goes on increases, the amount of the load criteria goes on increases if I go for a higher capacity. That's why this load test is conducted on only the induction motors of the certain capacity, below the certain capacity only. Now here, this test is conducted to determine the efficiency, torque, power factor and temperature rise at a different load conditions like 25%, 50%, 75%, 100% and 125% of the full load condition as per the standards of 4029. This load test is conducted according to the standards of 4029 of 1967, and induction motor is loaded at a different load conditions starting from 25%, 50%, 75%, 100% and certain percentage of overload. At each of the load conditions, we are going to determine the efficiency, power factor and the temperature rise and the torque. Now this test is simple, that is done by the help of this circuit here. We are going to connect all the meters like this, and at the starting we are going to keep the load on the, that is the induction motor rotor is free to rotate. Afterwards, what we do it is we give the supply, switch on the supply, switch on the auto transformer with AC supply and go on increase the voltage until the rated voltage is supplied to the induction motor. When I give the rated voltage, it rotates at the rated speed for which it has been designed, and note down all the reading, voltmeter, ammeter and 2 wattmeter readings as well as the load applied and the speed. This process is repeated for 25, that is load the induction motor the 25% of the full load condition using the breakdown arrangement. Note down all the readings, this one, wattmeter readings, speed S1, S2. Likewise, each step of the load condition is increased by 50%, 75%, 100% and 125%. In each of the load condition, all meters readings are noted down. Then afterwards, that is all the readings are noted down like this here at a different load condition. Then you have to find out the output. Then afterwards, the efficiency of the induction motor at a different load condition can be obtained with the torque at a different load conditions as such. This is about the load test on the induction motor. Now, once the load test is completed, let us see that how the power factor is determined. The power factor is determined, that is the power factor at which induction motor is operating. It can be determined by different methods. One, using the power factor meter, that there are power factor indicating meters are available, or maybe digital power factor meter available. Those meters are taken and they connected in the circuit, which provide the information about the power factor at which the particular induction motor is operating. This is the first method. Second method, knowing the power consumed by induction motor, the power factor is determined. I think from the previous data, the power consumed by an induction motor at the different load conditions is known. Accordingly, the power factor is determined by WT by root 3 VL IL. Root 3 VL IL. That is second method. Third method, by knowing the 2 wattmeter readings which you have taken at the different load conditions, that will be helpful to determine the power factor at which the induction motor will be in operation, calculated by this equation. Power factor is equal to the cos inverse of tan inverse root 3 W1 minus W2 divided by W1 plus W2. In this way, 3 methods are available to determine the power factor at which induction motor is operating. First method, directly with the power factor meter, insert in the circuit. Second one is knowing the power consumed by an induction motor at a different load condition. By the way of this equation, we can determine. Otherwise, the other method is knowing the wattmeter readings at a different load conditions. I can determine the power factor at which the induction motor will be in operation. This is about the determination power factor. Let us go for the next one, no load test. Now this no load test is conducted on induction motor to determine some of its performance parameters, that is no load current as well as the no load losses that exist in case of induction motor when it is operated at no load condition. These parameters will help in determination of or maybe finding out the equivalent circuit parameters of an induction motor. Now this test is also called as rated voltage test. Rated voltage test. Now we'll see that how it can be conducted. You can see the diagram here. The induction motor is kept under no load condition. That is, when I say the no load condition, the rotor should be free to rotate. Rotor should be free to rotate. Then afterwards, we make a connection. We connect the 2 wattmeters, ammeter and a voltmeter, and the complete setup is connected to the direct D-volt starter or maybe through an auto transformer, since we are giving the rated voltage. This is also called as rated voltage test on an induction motor. What we do it here, after making the connection, we give the supply, switch on the supply, we apply a rated voltage to an induction motor, and we try to start the induction motor either with a D-volt starter or maybe auto transformer starter, applying the rated voltage. When we apply the rated voltage, induction motor will be rotating at its rated speed. Then note down voltmeter, ammeter and wattmeter readings as W1 and W2, and total wattmeter reading at W1 plus W2, or maybe here with P1 by P1 plus with P2. By knowing the readings, we can confirm that this current reading, it gives a no load current, and wattmeter W0 gives a no load input, which is equivalent to the core losses or maybe the iron losses in case of the induction motor. From these parameters, I can determine the no load power factor, then X0 and R0. and magnetizing component, as well as the active component of the current by knowing the A0 as well as no load power factor. This is about the no load test. Now that after this, will let us have the summary of this the class what you had today. We have discussed the need of the testing, why the testing of the induction motor or maybe of an induction motor is essential. Not only the induction motor, all electrical equipment or maybe equipment which are manufactured or need to be tested for their performances, whether or not it gives according to the design criteria or not. That's why the testing is important, since we are speaking about the electrical system and we require to have the testing of an electrical equipment, that is an induction motor. Then afterwards we gone through a different method, that is measurement of insulation resistance measured with a different methods. If a method is not available, we go for the different methods, whichever the method which is available for measuring the insulation resistance in mega ohms can be used. If not, if a mega is available, mega can be used. Then afterwards we came to know about the PI, which is called the polarization index, which is a good tool to indicate the degree of dryness. Depends upon the type or the class of insulation you use it. The PI should be greater than some values. If it becomes less than that particular value for an induction motor, then that particular induction motor should be dried until you get the PI value or maybe insulation resistance to the specified value according to the standards. Then afterwards we came to know that how you can conduct the load test to determine the efficiency, torque as well as the power factor. Then afterwards we came to know about the no load test, which is also called as rated voltage test, which helps us to find out the no load current as well as the core losses that exist in case of an induction motor as such. That is the no load test. All these topics which comes under the levels of L1 and L2, that is remembering and understanding. For the above topics, you can refer the books written by S. Rao with the title of Testing and Commissioning, Operation and Maintenance of Electrical Equipment. Other textbook which is available in the market written by Dr. Oral Chakasari with the title Testing and Commissioning of Electrical Equipment may be also referred. Thank you.